Welcome back to Chem Sleeping Lab, episode 4. Last time we talked about fire. Tonight we will talk about poison, but of course in a very calm way. You don't need to be afraid. You don't need to remember. Just close your eyes and listen to the rain. There is a very old saying in chemistry and medicine. It is from almost 500 years ago. A man said, "The dose makes the poison." What does that mean? It means almost everything can be toxic if the dose is high enough. And even a very toxic substance can be safe if the dose is low enough or there is no exposure. Let us start with water. Water is the chemical we talked about in episode 1. Water is essential for life. But if you drink an extremely large amount of water in a very short period, it can be harmful. It can dilute the salt balance in your body. Table salt, sodium chloride, also essential. But if you eat a huge amount at once, it is also harmful. On the other side, substances we think of as poisons, like venom or strong acid, in extremely tiny, controlled amounts, can be used as medicines. This is not to say they are safe at home. It is just to show that toxicity is not only about what the substance is, but also about how much. So, in toxicology, the study of poisons, we never just ask, is this toxic? We ask, how toxic is it? At what dose? And by what route? This brings us back to our most important formula. Risk equals hazard times exposure. Hazard is how toxic a substance could be. Exposure is the dose that actually gets into you. Safety is about controlling the dose. Dose is not just amount. It is also about time. There are two main types. The first is acute toxicity. Acute means short term. One time or a few times within a day. For example, you accidentally inhale a lot of cleaning spray at once and you cough. That is an acute effect. It happens quickly. The second is chronic toxicity. Chronic means long term, small doses, but many times over months or years. For example, breathing a small amount of dust every day for many years. The effect may not appear quickly, but after a long time, it can appear. There is also local effect and systematic effect. Local effect is where the chemical touches. For example, a corrosive liquid touches skin and irritates the skin right there. Systematic effect is after the chemical gets inside the body, travels in blood, and affects an organ far away, like liver or kidneys. Why do we need to know this? Because controlling exposure means thinking about both, not just one big accident, but also small, repetitive exposures every day. In the lab, the best habits are very simple and boring. Do not eat or drink in the lab. Wash your hands after handling chemicals. This reduces chronic low-dose ingestion and skin exposure that you may not notice. How does a chemical get into the body? There are 4 main routes. 1. Inhalation. Breathing in. This is the most important route in most labs and factories because gases, vapors, and fine dusts can be invisible and they go directly to lungs and then quickly to blood. That is why ventilation is always the first engineering control. A fume hood, an open window, working outside, those all reduce inhalation exposure. 2. Skin absorption and skin contact. Some chemicals can pass through skin, especially if skin has small cuts. Others do not pass through, but they irritate or corrode the skin. Wearing the right gloves and long sleeves reduces this. But gloves are the last line, not the first. Removing the chemical or using a tool is better. Three, ingestion, swallowing. That sounds strange, but it happens more than we think. Touching a contaminated surface, then touching your mouth, or eating without washing hands. That is why we never use lab beakers as cups, and never store food in a chemical fridge. 4. Eyes and injection. Eyes are very sensitive with a lot of water. Vapors can irritate eyes easily. That is why safety goggles matter when there is splash risk. Injection is when a sharp object or high pressure spray pushes chemical through skin. It is rare but serious. If you remember only one thing from this part, remember this. In daily life and in the lab, inhalation is normally the fastest route. So we protect our air first. How do we know how hazardous the substance is? Scientists use tests, and they put the results in the safety data sheet, SDS. You will sometimes see letters and numbers like LD50 and LC50. LD means lethal dose. LC means lethal concentration in air. 50 or 50 means 50% of test animals. So LD50 is the dose that would be lethal to 50% of animals in a test. LC50 is the concentration in air that would be lethal to 50%. That is why we do not rank chemicals as safe or dangerous by one number. We look at hazard and we control exposure. In SDS Section 8, Exposure Controls and Personal Protection, you can see how to control it. In SDS Section 11, Toxicological Information, you can see toxicity, skin irritation, eye irritation, whether it is a sensitizer, that can cause allergy after repeated exposure. So our job is simple. Keep the dose low, keep it out of your air, off your skin, out of your mouth and eyes. Let us review. The dose makes the poison. There are 4 main rules: inhalation, skin, ingestion, and eyes. Inhalation is usually the most important. LD15 and LC15 are just ways to measure hazard. Risk is still hazard times exposure. You do not need to remember the numbers. Just keep the habit. Ventilate. Wear gloves and goggles when needed. Wash hands and keep food away from chemicals. That is all for tonight.